Hello, this is Lahari 21MIS0091 and today we'll discuss about proxy pattern. A design pattern is a reusable solution to a commonly occurring problem in software design. It provides a general approach to solving a specific design in a way that is both effective and efficient. Design patterns are not specific implementation algorithms, but rather general templates or blueprints that can be applied to various situations. They help developers communicate about common design problems and solutions, making it easier to understand and collaborate on software development projects. By using design patterns, developers can benefit by reusing the code again, increasing the scalability, improving maintainability, and better performance. There are several categories of design patterns: creational patterns, structural patterns, and behavioral patterns. Creational patterns are concerned with object creation mechanisms. Structural patterns deals with object compositions and relations. Behavioral patterns focuses on communication between objects and their interactions. Proxy pattern. The intent of proxy pattern is to provide a surrogate or placeholder for another object to control access to it. This pattern is also called as surrogate. Proxy is applicable when there is a need for more versatile or sophisticated reference to an object than a simple pointer. The proxy class typically handles the creation, destruction, and communication with the real object, allowing for additional functionality to be added without changing the existing codebase.
Now let us see the motivation for using proxy design pattern. One reason for controlling access to an object is to defer the full cost of its creation and initialization until we actually need to use it. Consider a document editor that can embed graphical objects in document. Some graphical objects like large raster images can be expensive to create, but opening a document should be fast. So, we should avoid creating all the expensive objects at once when the document is opened. The solution is to use another object, an image proxy, that acts as stand-in for the real image. The proxy acts just like the image and takes care of instantiating it when it's required.
Now let's see the structure of proxy pattern. We have a client that is requesting uh, Now let's see the structure of proxy pattern. We have a client that sends request to the subject and a proxy is generated that is connected to the real subject. Now these proxies are responsible for whatever the client has requested. And this is the structure when the system is running. The image at the bottom is the structure of proxy pattern during runtime. A proxy is linked to a real subject, and when a client has requested something, a proxy is responsible for encoding the request. Let's see the participants of proxy design pattern. We have a proxy that maintains the reference that lets the proxy access the real subject. Remote proxies are responsible for encoding a request and its arguments and for sending the encoded request to the real subject in a different address space. Virtual proxies may catch additional information about the real subject so that they can postpone accessing it. For example, the image proxy from the motivation catches the real image's extent. Protection proxies check that the caller has the access permissions required to perform a request, and the other participant is subject. This defines the common interface for real subject and proxy so that a proxy can be used anywhere when a real subject is expected. And we have the real subject. This defines the real object that the proxy represents. When to use proxy design pattern? The proxy design pattern is suitable for various situations where you need to control access to an object or introduce additional functionality around it. If you want to restrict access to certain objects on permissions or conditions, a proxy can be used to enforce access rules. Remote proxy. When dealing with distributed systems or remote services, A proxy can act as local representative for a remote object. Logging and monitoring. Proxies can be used to log method invocations, monitor resource usage, or collect metrics without modifying the core functionality of the object. This enables you to gather valuable insights into a system behavior without cluttering the main codebase. When not to use proxy design pattern. Simple object access. If the objects being accessed are simple and do not require additional behavior or access control, using a proxy may be overkill. Increased complexity. Introducing proxies can make the system more complex, especially if there are multiple layers of proxies or if the interaction between proxies and the real objects are intricate. Unnecessary abstraction. If the use of proxies introduces unnecessary abstraction layers without providing clear benefits in terms of code maintainability, flexibility, or scalability, it might be better to keep the design simpler and more straightforward. Advantages of using a proxy design pattern. Controlled access. Proxies enable controlled access to the underlying object, allowing you to enforce access control rules, permissions, or constraints. This helps in enhancing security and preventing unauthorized access to sensitive resources. Remote access. Proxies facilitate communication with remote objects or services, acting as a local representative for remote entities. Performance optimization. Proxies can be used to optimize performance by introducing caching mechanisms, reducing network overhead, and optimizing resource usage. They allow you to implement perform-related optimizations without directly modifying the underlying object. Reduced coupling. Using proxies can reduce coupling between components by providing a layer of abstraction between the client and the underlying object. Additional functionality. Proxies allow you to add additional functionality around the underlying object transparently. This includes logging, monitoring, error handling, and validation, or any other cross-cutting concerns without modifying the core functionality of the object. Now let's see the disadvantages of using a proxy design pattern. Performance overhead. Proxies can introduce performance overhead, particularly if they involve additional layers of abstraction, network communication, or resource-intensive operations such as caching. Potential security risks. While proxies can enhance security by enforcing access control rules, they can also introduce security risks if they are not implemented correctly. Limited usefulness in simple scenarios. In simple scenarios where objects do not require additional behavior or access control, using proxies may be unnecessary and add unnecessary complexity to the code base. Complexity in debugging and testing. Proxies can introduce additional complexity in debugging and testing as they add an extra layer of abstraction between the client code and the real objects. Now let us see a real-time example that uses the proxy design pattern. We have a client and we have an image server that performs the following functions: display image and upload image. Now an image manager proxy is generated to display the image and upload the image, and the client contacts with the proxy but not with the direct server. We also have image manager proxy that connects with the image manager to perform the task that is requested by the client. Now, we also have a sample code that tells us how the implementation is done. We have a real subject that is named with the class real image that has the functions load file and file name. And we have few print statements that helps us to load the image and display the image. We also have another class called proxy image, which bears the objects for methods that have been initiated in the previous class. In this way, we can access the methods that are initiated in the real image using proxy.
Overloading the member access operators in C++. C++ supports overloading operator, the member access operator. Overloading this operator lets you perform additional work whenever an object is dereferenced. This can be helpful for implementing some kinds of proxy. The proxy behaves just like a pointer. This approach lets you call image operations through image pointer objects without going to the trouble of making the operations part of the image pointer reference. Overloading the member access operator isn't a good solution for every kind of proxy. Some proxies need to know precisely which operation is called, and overloading the member access operator does not work in those cases. Thank you.